Thank you for your interest in the CLAM field extraction monitoring device. The CLAM, or Continuous Low-Level Aquatic Monitor, uses the same solid phase extraction media used in labs every day for water analysis and puts that media in the field for in situ extraction. Using precision micropumps from the medical industry and 4 AA batteries, the CLAM is able to extract up to 100 liters of water continuously for up to a 36-hour deployment event. This continuous large volume sample allows the magnification of contaminants to be seen at up to 100 times the level of a 1 liter grab sample. It also represents up to a 36-hour video of what is in the water versus a 1 or 2 second snapshot in time. The extraction disc will retain a wide variety of nonpolar and polar compounds such as pesticides, TPH, PAHs, PCBs, pharmaceuticals, and contaminants of emerging concern. These compounds can typically be seen at parts per trillion levels and in some cases even parts per quadrillion. We are now going to show you a real-life deployment of CLAMs where Bayona Creek meets the Pacific Ocean in Los Angeles, California. The area has been scouted and the appropriate location has been chosen to lower the CLAMs from the bridge. A stainless steel chain was acquired which will stay completely submerged even in low tide. The chain was wrapped around one of the bridge railings and locked to itself. Once the proper position on the other end of the chain was identified, the chain was laid out on the deck surface ready for the attachment of the CLAMs. Heavy-duty tie wraps are ready for attachment as well as a lock to lock the CLAMs to the chain for security. To determine the total volume of water extracted by the CLAM during a deployment event, a calibration of initial flow rate and a calibration of ending flow rate are performed. Because the CLAMs are being lowered from a bridge in this deployment, a bucket of water from the same source is needed to perform the calibration. The calibration instructions would all be the same if done just in the water as opposed to in a bucket of the water. The bucket should be rinsed several times before filling and should be filled shortly before calibration so the water in the bucket is representative of the water to be sampled. Now it is time for the initial flow rate calibration. 4 new Ultimate Lithium AA batteries are seated in each battery pack. It is critical to use the Ultimate Lithium batteries as our studies have shown that these highest rated AA batteries will run about 40 hours steadily before stopping. That is why we indicate the CLAM maximum deployment at 36 hours. Once the batteries are seated in their holder, check the rest of the CLAM assembly. The extraction disc should be removed from its packaging and should be labeled with a marker or Sharpie or other method so each disc ID is clear and will stay with the disc on all forms and onto the lab. The red lure lock fittings should all be removed and the extraction disc should be secured to the front of the CLAM before turning on the pump. Now simply plug in the battery holder to the fitting in the CLAM and make sure the pump is now running. The pump can run in air or water without harming the pump, but the extraction disc should always be attached to the CLAM before starting the pump, as any solids that could reach the pump if the extraction disc were not attached could cause problems for the pump. Now ensure the O-ring is in good condition and thread the end cap in place over the battery holder. And make sure it is a snug fit so that water cannot find its way into the battery compartment. Now thread the front cap over the extraction disc. The CLAM should now be running and feel secure and tight. Now lower the CLAM into the bucket until it is completely submerged. The air will need to be out of the system before calibration. Once both units are running, it is now time for the calibration of initial flow rate. Remove the plunger from the syringe included in the Pelican case. The tube attached to the syringe will have a lure lock fitting on the other end. Attach the tube with this fitting to the outlet fitting on the side of the CLAM while keeping the CLAM completely submerged. Shortly, you should see water coming into the syringe. Hold the first CLAM upright so that it is still completely submerged, but so that the extraction disc is facing up. Look for any signs of air still coming out of the disc or through the tube. Moving the CLAM around with the extraction disc facing up should help get all the air out of the system. Once it seems the air is out of the system, it is time to calibrate. Start by recording the time in the field chain of custody form. Using military time will make calculations easier. Now, hold the clam level but still submerged in the bucket. Make sure the tube is not kinked and keep the bottom of the syringe close to the water level, as not to induce too much head on the pump by having it much higher than the outlet fitting on the clam. Keep the syringe emptying out while viewing a second hand on a watch or preparing to start a stopwatch. At an even time interval, turn the syringe upright and begin timing. As the initial flow rate is typically higher than 60 milliliters per minute, a 30-second calibration of initial flow rate is usually done, and then that number is doubled to give a milliliters per minute value. At 30 seconds, view the amount of water collected in the syringe and record. This calibration is typically done at least 3 times, ensuring that the last 2 calibrations are the same. Record the initial flow rate of the clam in milliliters per minute on the chain of custody form. In this case, a second clam is being deployed as a duplicate, so repeat the same initial calibration process for the second clam. Now remove both clams from the bucket of water and secure to the chain using the heavy-duty tie wraps and lock. The pumps will still be running and will be taking on air, but as soon as they are back in the water, they will come right back to equilibrium with the initial flow rate. Once the clams are secured and calibrated, they are lowered into the water for the extraction event. In this case, we have returned 29 hours later to retrieve the clams to be in conjunction with the grab samples taken by the City of Los Angeles. An ending calibration will need to be done for final flow rate, so total volume through the disc can be calculated using average flow rate. The same process as the initial calibration is repeated. Once the tie wraps are cut and the lock is removed, the clams are placed back in the bucket, and once again care is taken to make sure the air is out of the system before final calibration. It is common for each calibration to get a little bigger flow rate than the last when all of the air is not yet out of the system. That is why we recommend at least 3 calibrations, with the last 2 being identical. For the post-calibration, the ending flow rate will often be less than 60 milliliters per minute, so 1-minute calibrations can be done as opposed to 30 seconds. Record the final flow rate for each clam and the time. Now we have starting flow rate and starting time, and ending flow rate and ending time. Calculate the total number of minutes of deployment and average the starting and ending flow rates. Now the milliliters per minute average flow rate can be multiplied by the total number of minutes to get the total milliliters extracted through the disc. This is all recorded in the chain of custody to accompany the discs back to the lab. The lure lock fittings are placed back on both ends of the extraction disc, and the disc is placed typically in a plastic bag for transport back to the lab. Expect the disc to be discolored compared to a new disc. The discs do not need to be in a cooler, but should be kept from excessive heat and excessive light. Once back at the lab, it just makes sense to keep them in a cool place like a refrigerator until the back extraction of solvent is done for analysis. Now, very low level analysis can be performed because of the high volumes extracted.